Good morning, students. It's Ms. Carbajal. I'm going to help you with your chapter 14, 15, and 16 unit assessment, which you will be able to retake on Wednesday in the morning or in the afternoon, one-time sitting. Okay, right here I'm looking at some stuff that are some notes. You all were supposed to take notes throughout the last 4 or 5 weeks before Christmas time. You're going to have to know about atoms, atom structures. You're going to have to know about protons and neutrons and electrons. You're going to have to know their electronegativity. Protons are positive. Neutrons are zero, no charge. And then you have your electrons, which are negative charge. Remember, electrons are a lot smaller in mass than your protons. You will be given pictures of atoms, and it'll tell you the number of protons, number of neutrons, the number of electrons. You have to know if they're the same element. The elements are the same only if they have the same number of protons. Remember, the number of protons are your atomic number. You will have to know what an You'll have to know what an energy level is. You'll have to know how to read the periodic table. Right up here, it's showing you the periodic, what an element will look like on the periodic table and how to read it. Remember, the bottom number here is the atomic mass number. It's an average. Up top here, the number 22 is the number of protons. That's your atomic number. Sometimes it'll have your oxidation number on the top. Here are some features of metals, nonmetals, and metalloids. You have to remember that mercury and bromine are liquids at room temperature. On the periodic table that I gave you in the beginning of the unit, I told you to the periodic table tells you how you find the atomic number, which equals the number of protons, which equals the number of electrons, but it always equals the number of protons. You have to know what the chemical symbol is, the chemical name, the atomic weight. Atomic mass is the number of protons plus neutrons. If I give you an isotope and it's like it says carbon 13, you would look on the periodic table for carbon. You could see it down here. Carbon is 6 protons always. If I told you carbon 13, you would take 13 minus the number of protons and you will get the number of neutrons. Okay? That's how you would solve for that one. The key here tells you all the different things from your periodic table, but you will not have the same periodic table. Remember, you need to know your oxidation numbers here. The lithium to francium are your alkali metals, highly reactive. Then you have your alkaline earth metals, which have 2 valence electrons. Your alkali metals here have 1 valence electrons. Over here, the boron family, group 13 is going to have 3, 14 is going to have 4, so on. Here are our noble gases, also known as inert. Recall that they have 8. They're stable. Do they have an oxidation number? Absolutely not. Their oxidation number is 0. They are stable. They follow the octet rule. You need to know that. So sometimes it's called a complete atom, and that means it has a charge of 0. Here are your halogens, highly reactive. They have 7 valence electrons. They want to get that 8th one. Let's see. Okay. You have to know the difference between strong nuclear force, electromagnetic force, and a weak force. Remember, the strong nuclear force occurs in the nucleus. That's your protons and your neutrons holding together. The electromagnetic force, just think about it, is your protons, which are positive, and your electrons, which are negative. That's what's holding those together. If I ask you what is the number of, what's the charge in a nucleus, think about it as in math. If you have 5 protons and 5 neutrons, you have 5, positive 5 plus 0, that'll give you a positive number. Got it? If I ask you about the charge in the orbitals, it would be negative because the orbitals, the energy levels, only contain your electrons. Your electrons are negative. Okay, let's see. You have to know what the charges are. Electrons are bound to the nucleus by electromagnetic force. A particle with 0 charge is your neutrons. Charge on a proton is going to be plus 1e. The charge on an electron is going to be negative 1e. The mass of an atom is determined by the number of protons plus neutrons. You have to know what an ion is. You have to be able to understand how to read the periodic table. Across are your periods. So if you look at it on the first period, you only have 2 elements. That's why the lowest energy level only can fill up with 2 electrons. If you go to the second period, it has 8 elements. That's going to be able to fill up all the way across to 8 electrons. The third period is exactly the same. It could hold up to 8 electrons when it's filled. All right. Inside an atoms, you have to know the rules for the electrons. The energy of an electron has to match one of the energy levels in an atom. Each energy level can hold only a certain number of electrons. So in period 1, it can only hold 2 electrons. As the electrons are added to an atom, they settle into the highest unfilled energy level. Okay? Got it? All right. Let's think. You have to know what the spectral diagram is. I can't remember what page that is. Remember I talked to you guys about fireworks. When you see them, sometimes they're all in white, sometimes they're all in red, sometimes they're all in blue. That's because the light, the photons will jump and it'll let off a different color for different elements, and because they have different wavelengths. So that's what is represented in a spectrum. Each line is a different color of light, and that will tell you which element you have. You have to know what the uncertainty principle is. You should know the characteristics of a nonmetal and the characteristics of metals and metalloids. You should be able to look, if I told you neon, and I asked you the question, how many energy levels are in neon? There are 2 energy levels. It will have 2 electrons in the first energy level, and then neon will have 8 electrons in the second energy level. If I was looking at oxygen, it's in the second period. It's going to have 2 energy levels. In the first energy level, which is the lowest energy level, it will have 2, and then it will have, let's count, 1, 2, 3, 4, 5, 6. 6 valence electrons. Okay? You should know that the second row of the periodic table has 8 elements because it could hold 8 electrons. The third one will have 8 elements too because it could hold 8 electrons. Alkali metals are highly reactive with oxygen because they are found in group 1. You should know that evidence of chemical change, evidence of a physical change. Remember, changing states is not chemical change, is a physical change. You should know what ductile means. You should know what malleability means. You should know about periodicity. That's the patterns. That's your melting point and your boiling point. That's along the periods. As they are filled up with the valence electrons, they show a certain pattern. Atoms form chemical bonds with other atoms. That is in chapter 16, the last one, because most atoms are unstable. The only atoms that are stable are our noble gases because they already have the 8 valence electrons. They're filled, they're satisfied. So You have to know that ionic bonds are usually far apart. These are our donors. On this side are acceptors. When it's close together, usually nonmetals, those are your covalent bonds. They're sharing electrons. You should know how to do the Lewis dot diagram. So everybody in the halogens are going to have 7 dots in the Lewis dot diagram. You should know how to count each molecule. If I gave you a molecule, how to do that, and I taught you guys how to do that before. Let's see. All right. Here are some pictures of properties of metals, properties of nonmetals, properties of metalloids. You need to go back and look at your properties of your proteins, your carbohydrates, your lipids, fats. You should know about photosynthesis, the oxidation numbers, which I taught you. The oxidation numbers, remember, +1, +2. Then you have your 0, -1, -2, so on. And then this is going to be -3 here. And then you have +4 above the carbon. Remember how special carbon was? It has 4 valence electrons. It could form different types of bonds. And then this one is +3. Okay. So what I suggest you do is go over your notes, look at your notes, go through the concepts, look at how the periodic table is set up. I think I covered everything that you need to know. Know what an ion is. Ions, ionic bonds are separated from each other. You should know that most of the elements in the periodic table are metals. If you look all along here, except for hydrogen, all along here are your metals. Then you have your metalloids along here. I think I covered everything that you need to know. Transition metals from here to here. Know what groups those are in for your transition metals. Ions, remember, have an electrical charge. That means it either gained or lost an electron. It's transferred. And I think that's it. Study well. Make sure you understand the material. If you have any questions, send me a text. Good luck.